Okay, good morning to all of you. As you all know that exam is knocking the door, so there's a very less time to conduct online class. So I am going to upload this video regarding problem analysis on DSP. So numerical problem analysis of DSP, that is digital signal processing. So today I will start with the very fundamental topic of your module 1, that is signal and systems. So in signal and system, very basic numerical analysis, numerical problems will be there, which may be which may come to your question. So first one is periodic signal related. Signal related problems. In this type of problems, you will find the question like this. They will give you in the question paper, they will give you some function of signal, and you have to find out whether the signal is periodic or not, or you will find out whether you will find out what is the fundamental period of that signal. So very first type of example, that is find out the fundamental frequency of given functions or signals. The function is nothing but the representation of signal. So in this such type of problems, I am giving you the first example. Suppose xt equal to sine 15 pi t. Now you have to find out the fundamental period. Okay, let us say fundamental frequency is not a good term. Instead of this, fundamental period of given signal. So so you all know that this sine 15 pi t is the nothing but the representation of sine omega t, and omega 2 pi f. Okay, so again, so fundamental period equal to, that is the t0, which is 2 pi by omega or omega 0, and this omega 0 in this case is 2 pi. Okay, this is the basic fundamental. Sorry, 15 नहीं, यहाँ पे 15 pi. So because there is a 15 pi t, so omega 0 is 15 pi. So 2 pi by omega 0. Now omega 0 is 15 pi, so 2 by 15. So this is the fundamental period of the x of t. Now Calculate the value of 2 by 15. That is 1.3, sorry, 0.133. This is the fundamental period. And what is the unit of the fundamental period? That is T is time, and so the fundamental period is second. So 0.133 second. Now next one is, I am giving you another example. X2, let us say this is x1 and this is x2. X2t equal to sine 20 pi t. So find out fundamental period. So similarly here, this is nothing but the representation of sine omega t, where omega is 20 pi. So omega is 20 pi. So I can say omega 0 equal to 20 pi. So the fundamental period is T0 equal to 2 pi by omega 0. So 2 pi by omega 0 is 20 pi. So 1 by 10, that means 0.1, and the unit is second. So this type of problems you will get in your MCQ type question. They will give you a function and asking our fundamental period, and they will give you 4 options, and you have to solve the problem like this. Now next is whether the signal is periodic or not. So now similarly I am taking the same case, that is sine 15 pi t, whether the signal is periodic or not. You will say that the time 15 pi t. Okay, so sine omega t, fundamental period. So this is omega t. So after this particular instant the signal will repeat itself. So it is periodic function. Again similarly sine 20 pi t. After the particular time function it will repeat itself. So this is periodic signal. These two signals are periodic. And this type of question also you will get in your MCQ. So without wasting time, just by seeing the equation you can predict whether the signal is periodic or not. Okay, now I am giving you another example of finding the signal, whether the signal is periodic or not. Like suppose x3t is equal to x1t plus x2t. That means x1t is sine 15 pi t and x2t is sine 20 pi t. So x3t will be sine 15 pi t plus sine 20 pi t. Now to find out whether it is periodic or not, you have to find out the individual fundamental frequency of x1 and x2 and find out its ratio. If the ratio will be the ratio of two real number without fraction, not fraction number, that is ratio will be of real numbers, then it will be known as periodic signal. Else it will be called as non-periodic signal. So let T1 is the fundamental हेलो, अच्छा ठीक है। Okay, so T1 be the fundamental period of x1t, which is 0.133 second, as we already solved this question, and T2 is the fundamental period of x2t, that is also 0.1 second. Okay, so now the ratio of T1 and T2 will be 0.133 by 0.1. See, in both the part, numerator and denominator part, the number is not a number is a fraction number, or number is a number having decimal part. So I can say this is not a periodic signal, or I can say the signal is non-periodic. Okay, so this type of question you will get in your exam in MCQ type question, under MCQ type question. Next is power and energy related problem. Next one is power and energy related problems. In this type of question, in this type of problem, you will get the question like this. They will give you a function or a signal which will be represented by a function of x, function of y, whatever it may be, and you have to find out what is the energy of the signal and what is the power of the signal. So I'm giving you a example. Suppose x of n, it is given it is given. Okay, in this question it is given, and you have to find out power and energy of x of n. So you have to find out this. So now what you will do in this type of question? So first you have to remember the energy, how to calculate the energy, the function, energy of the signal, energy of signal, as well as power of signal. Okay. So as you already learned about the energy function or energy equation of a signal equal to n equal to 0 to infinity mod x of n whole square. This is the energy. And what about the power? The power signal is limit tends to infinity, summation n equal to 0 to infinity x of n square 1 by n plus 1. This is the equation of energy of a signal and the power of a signal. Now you have to find out the energy as well as power of x of n. So first we will find out, as per the question, power of the signal. So power of x of n. So what will be the power of x of n? Suppose P x of n. I can write the notation P of x of n, that is power of x of n. So limit n tends to infinity 1 by n plus 1 n equal to 0 to infinity x of n whole square, that is x of n is 4 minus 1 to the power n. So 4 minus 1 to the power n whole square. This is the power. So now solve it. Limit n tends to infinity 1 by n plus 1 4 square, that is 16. 16 will be out of this summation. N equal to 0 to infinity minus 1 square, simply. So now this part I can write minus 1 to the power square. I can change the power notation, meaning will be same.